Alright, let's take a look at our lesson on nth roots and radicals. So in this little box we've got for any real numbers a and b, any positive integer n. So if a to the n equals b, then what we would say is that a is the nth root of b. That's just vocabulary. A would be the nth root of b. Okay. Now we're going to be dealing with just principal roots. Okay, so let me give you an example. What is a principal root? If I asked you what the square root of 25 was, that is going to be simply 5. Okay, it's not going to be plus or minus 5. Okay, this is called the principal root. It's just, and if you put that in your calculator, if you put in your calculator square root of 25, hit enter, it would tell you 5. It would not tell you plus or minus 5. Okay? The only time that we get plus or minus 5 is when we're solving an equation. You know, for example, if I had x squared minus 25 equals 0, you know, and then I was solving, I moved the 25 over, and I square rooted both sides. In this case, I would get a plus or minus 5. Why? Well, because I'm solving for the equation. I want to know what x could be. What's possible for x to be to make that equation true? And since I'm squaring x, it could be plus or minus 5. So that is not what we're doing here with this, you know, the square root of 25 is 5. So just want to make that clear. All right, so this is should be a bit of a review. Let's take a look. We're looking at, we're going to evaluate, which means, or simplify. We can use those words, evaluate, simplify. We need to come up with a simplified answer. So this is a cubed root, which means that I am looking for groups of 3. So I would do a factor tree, which you guys know I love factor trees. So 9 times 3, 3 times 3. And we see that we have one group of 3, which means, if you recall, then there's nothing left under the cubed root. It just is 3. And so that is our very first cubed root in this lesson. Number 2, we have a 5th root. And the negative kind of sometimes troubles students, so I'm going to rewrite it. You don't have to do this, but I think it's just helpful that we really understand what's going on. If I have the 5th root of negative 1 times the 5th root of 32, that would be the same thing that I have here. The 5th, I'm just splitting it up so that we can really kind of dissect what's going on. This negative 1, I know that negative 1, so it's to the 5th power, so I know that negative 1 times negative 1 times negative 1 times negative 1 times negative 1, those are all negative 1, right? Negative 1, you know, multiply it 5 times, you get negative 1. So there's 5 of those, so that comes out as a negative 1. That's just part of the answer. Now the 32, we're going to do just a traditional factor tree. And of course, you don't have to do this business with the negative 1. I just wanted to make sure we understood why our final answer is going to be negative. Okay, so equals, so negative. So let's see, 32 would be what, 8 times 4, and that would be what, 4 times 2, 2 times 2, and 2 times 2. So I'm looking for groups of 5. 1, 2, 3, 4, 5. Oh, I do have a group of 5. Okay. So my final answer would simply be negative 2. There would be nothing left under the radical. All right, let's look at our last example on this page. We're looking for groups of 3. Okay, groups of 3. So let's deal with the number first. We know that's 9 times 3 and 3 times 3. Okay, that's nice. That's 3 3s. We're liking that. Okay, that's going to come out from under the radical. Remember, the variables are a little different. Okay, they're a little different than numbers. We need to think, remember we just did the exponent lesson yesterday. So when I'm multiplying common bases, what do I do to the exponents? I add them, right? I add them. So if I'm multiplying, let's see, what would I add 3 times to get a 12? Let's see, to the 4th, because I'm looking for groups of 3, right? That's what I would prefer. Let's see, y to the 4 times y to the 4 times y to the 4. So I would do 4 plus 4, 8, 8 plus 4 is 12. So that is equivalent, and that's a group of 3. Okay, that's a group of 3. Okay, so let's investigate the z. Let's see, I could have z squared, and z squared. That would give me z to the 6. So I have an extra. Okay, this guy is going to be left inside under the radical, and these guys get to come out. So I've circled the groups of 3, and I've put a box in the leftovers that have to stay inside. So the groups of 3, a 3 is going to come out. Remember, we take one of those items out because they're in groups of 3. Y to the 4th, z squared, and we're going to have to leave inside the radical a z. Okay, and so that's how we would do that problem. All right, great. Let's go to the second page. See what we got going on in here. All right, let's look at, number 4 looks a little crazy. Okay, so with radicals, I am allowed to rewrite this. So since a to the 9th over b to the 5th, there's no way to simplify that. Why don't we just rewrite it as a radical on top of another radical? That seems like we can work on that. Okay, let's work on that. So, okay, so let's see. So I'm looking for groups of 2 because it's a square root. Perhaps we remember if we want to do a little scratch work over here. So a to the 9th, looking for a group of 2. So let's see, a to the 4th, a to the 4th. So 4 plus 4 is 8. So I have another a left over. So that gives me, here's my group of 2. So I've got a to the 4th. So let's go down here. So this is going to give me a to the 4th, and then the square root of a is going to be left in. Okay, good. Then we've got in the denominator, we've got 5 of those. So let's go over here and do some scratch work. We've got 5. I need groups of 2. So let's see, what could we do? We could do b squared, and that leaves another b. Whoops, not p, b. And I have a group of 2. Okay, so then these guys, the extra guys have to stay under the radical. So I have b squared square root of b. Now, in this unit, we need to be sure that there are no radicals in the denominator. That's like something that we're going to have a rule for this unit where there's no radicals in the denominator, because that's a proper way to simplify. So if I want to get rid of the square root of b in the denominator, I would simply multiply by the square root of b over the square root of b. Perhaps you remember rationalizing from geometry. So let's see, what would we get? We would get a to the 4th, and then I'd have square root of a times square root of b is square root of ab over. Then I've got a b squared, and then square root of b times square root of b is b. So b squared times b would give me b cubed. All right, and there's that answer. Okay, let's look at number 5. So number 5, we got some crazy stuff going on here, but we do have a radical times a radical. Let's deal with these numbers first. Okay, I would multiply this number times this number because they're outside the radical. They're really just hanging around. So 6 times 4 is 24. Okay, and then I can bring all of that underneath one radical. Just like I did up here when I multiplied the square root of a times the square root of b and got the square root of ab, I can do the same scenario down here. So let's just write it all out. So I have 8 times 2, and I'm just going to group the things that are alike together. A c cubed times a c, and a d to the 5th times a d cubed. Okay, so we're just going to take this slow, step by step. Okay, so that would give me, let's see, I'm looking for groups of 2. So, I mean, I can do 8 times 2 and get 16. That's fine. And there's multiple ways to do this. So there's a group of 2. Then c cubed times c would be c to the 4th. So that would be like c squared times c squared. That's a group of 2. Then d to the 5th times d to the 3rd is d to the 8th. And that would be like d to the 4th, d to the 4th. Okay, so that's looking good. All right, so let's clean that up. It looks like I don't have anything left under the radical. That's kind of nice. So I would have like a 24 times 4. So 24 times 4 times c squared times d to the 4th. And then 24 times 4 is 96. So 96c squared d to the 4th would be my final answer. Okay, that's number 5. Let's go back up here and look at number 6. Very similar to number 5. It's just instead of doing a square root, we're doing a 4th root. Now, I want to make note that if these were different kinds of roots, I would not be able to bring those together. Like if this was a square root and this was a cubed root, yeah, no going. I can't bring them under the same radical. They have to be the same kind of radical. See how this is a 4th root and this is a 4th root? These I am allowed to bring together underneath one radical. So 2 times 3 is 6. And then I have the 4th root of, so then I have an 8 times a 2 times the x cubed times the x to the 5th times y squared times y squared. And again, I'm just taking it slow. You can skip steps if you want to. 8 times 2 is 16. X to the 3rd times x to the 5th is x to the 8th. Y squared times y squared is y to the 4th. And I'm looking now for groups of 4. I want groups of 4. Okay, so let's see. That's 4 times 4. Oh, looky here. We've got a group of 4 2's. Okay, good. I'll have no numbers left inside the radical. That's great. Let's see. I'm looking for groups of 4. If I want this to be into 4 groups, what would I do? Let's see. What about x squared? Would that do it? X squared, x squared, x squared, x squared. Let's see. 2 plus 2 plus 2 plus 2. Yeah, that's 8. So that's a group of 4. Yay. And this one, I'm looking for groups of 4. So that would basically be y times y times y, right? That's a group of 4. Okay, fantastic. It looks like nothing's left under the radical. Okay, that's kind of nice. So 6 is already out there, times 2. Then I have the 4th root of, oops, nope, there's no 4th root left, right? Because we're all out. I've got x squared and y. So my final answer would be 12x squared y. Okay, yay. Let's look at number 7. So we did a little bit of adding and subtracting radicals before. Should be a review. We're just going to kind of dig in. Remember, we can't, unlike multiplying radicals together, you know, where we could, like, the square root of 2 times the square root of 5 is the square root of 10, where we can do stuff like that. We can't do that with adding and subtracting. You know, adding and subtracting is just fussy, isn't it? It's just fussy. So in order to add the radicals together, we have to be sure we have the same kind of radical. So we're going to have to try to simplify these things. Let's see what we got going on. This is a squared square root. They all are square roots. So we're looking for groups of 2. So let's see, what is this? This is 4 times 3, or 2 times 2. There's a group of 2. This would be what? 9 times 3, or 3 times 3. There's a group of 2. Ooh, 128. That looks fun. What is that? That is, and usually when I have like that, you know, big number like that, I just divide by 2 if it's even. And it is, so 64 times what? Times 2. And that is 8 times 8. So it's a group of 2. Okay, great. Let's rewrite. So I have 5 already out there times 2. And then what's left inside is the square root of 3 plus 2 times 3, and again what's left inside here, so these in boxes are left inside. square root of 3 minus 8 square root of 2. Okay, well, we can do some things. We can only add together the radicals that match, right? This radical matches this radical, so I'm going to be able to add those first two together, but I'm not going to be able to add this last one together. That is root 2. That means it's going to have to stay by itself. So I basically have 10 root 3 plus 6 root 3 minus 8 root 2. So as I said, we can combine the common radicals together. So 10 root 3 plus 6 root 3 gives me 16 root 3 minus 8 root 2. And that is basically all I can do. Okay, so that's some examples of adding and subtracting radicals. Yay. Ooh, foiling. That looks fun. All right, so we're going to do first times first. So 4 times 3 is 12. The square root of 3 times the square root of 2 is the square root of 6. Okay, so we did the square root of 3 times the square root of 2. Let's do scratch work over here. The square root of 3 times the square root of 2 is the square root of 3 times 2, which is the square root of 6. Okay, so that's where I got that from. That's first times first. Outside, FO, so outside these two. So 4 times 6, 6 times 4 is 24, root 3. Okay, now let's do inside. So that is what, 15, and square root of 2 times the square root of 2 is the square root of 4. And then last times last. So what is that, negative 30 root 2. Okay, so let's work on cleaning that up. So we can see, what do we got going on? We've got 12 root 6. I don't have another root 6, so that's not going to work. So I've got a 12 root 6. And I don't have another root 3. Okay, that's got to stay by itself. Now root 4 is 2. We know that. Root 4 is 2, and so 2 times 15 is 30. Okay. And then I don't have another root 2, so I actually have to just leave them all like that. I can't combine them together at all. And the roots are simplified as they can be. There's no way they can go down any further. 6 is 2 times 3. There's no groups of 2, so that's not going to work. So we're kind of just stuck. We're just kind of stuck where we are. Okay. All right. So our last problem, to simplify something like this, we want to rationalize the denominator. So we want to get the radical out of the denominator. So how do we do that? Well, the way that we get the radical out of the denominator is to multiply by the conjugate over itself. And I know we've done this before. This is just a review. So we're going to multiply by the conjugate over itself. Okay? So let's do that. So I'm going to work on the top, the numerator first. So 2 root 5 plus 2. I just multiplied that out. Now I'm going to FOIL out the bottom. Root 5 times root 5 is root 25. Root 5 times 1 is root 5. Negative 1 times root 5 is negative root 5. And negative 1 times 1 is negative 1. Okay, great. So I've got 2 root 5 plus 2 over, let's see, the square root of 25 is 5. Those cancel out. So 5 minus 1 is 4. Okay, great. That's looking good. So we have to ask ourselves, is there any way we could simplify that? Do we have like a GCF, a greatest common factor? We do in the numerator. Our greatest common factor is 2. So 2 times, or factor it out. And then we ask ourselves, oh, we love this question, is there anything we can cancel? Yes, we know 2/4 reduces to 1/2. So my final answer would be the square root of 5 plus 1 over 2. All right, great. And that finishes up our lesson.